Okay, so this problem is definitely a little bit complicated, but the first thing you got to do is realize that you've got to define f in terms of g. So it says f of x is x times g of x squared. So that means we need to come up with an expression for g of x squared. We have g of x equals 3 plus 4x, so that means g of x squared would just, everywhere there's an x, it's going to get replaced with an x squared. So it would be 3 plus 4x squared. So now we can say f of x is x times 3 plus 4x squared. And now you have f of x in terms of just x's, really. So we could simplify this and say f of x is, just distribute the x in there and get 3x plus 4x cubed. Then f prime of x would just be using the power rule, 3 plus 12x squared. So f double prime is, the derivative of 3 is 0, the derivative of 12x squared is 24x. So I think that's all they're looking for there for part A. For part B, we're going to do the same thing, basically. They're just changing what g of x is. So now we would say, okay, if g of x is sine of x, then g of x squared is sine of x squared. So all you're doing is replacing x with x squared. So we'll go about that and say, all right, now part B says we're still using the definition that f is x times g of x squared. So f of x is x times g of x squared, but g of x squared is the sine of x being squared. And so this is going to be a giant pain in the butt to get the second derivative, because we can't simplify this expression for what f of x is. We can't multiply it in like we did in this problem. So we're going to have to use the product rule to get the derivative of this. And when we get to taking the derivative of this part, we're going to need the chain rule. So the first derivative is going to get a little messy, and the second derivative is going to get even messier, I think. So just buckle up. So f prime is going to be the derivative of the first, which is the derivative of x, which is 1, times the second function, which is the sine of x squared, plus the first function, which is x, times the derivative of sine of x squared. So we're going to use the chain rule here. The derivative of sine is cosine of x squared, and then we take the derivative of what's inside, which is the derivative of x squared, which is 2x. So that means f prime of x is sine of x squared plus, 2x squared cosine of x squared. Just multiplying the 2x and the x together to get 2x squared. So there's f prime. So now if we want f double prime, we just are going to go through and take the derivative of this and add it to the derivative of this. But when we get to the derivative of this guy, we're going to need, again, the chain rule when we do that guy. So this f double prime is going to get a little messy here. So f double prime, there we go. So the derivative of sine of x squared, again, the derivative of the sine is cosine of x squared times 2x. Now, I might run out of room here, but we're going to get 2x squared, its derivative is 4x, times cosine of x squared, plus 2x squared times the derivative of cosine of x squared, which is negative sine of x squared times 2x. So, that's the answer. We can probably clean that up a little bit more, and we'll say f double prime is cosine of x squared multiplied by 2x. I would probably put that 2x in the front, but whatever. And now in the back here, we've got a 4x times the cosine of x squared. That's kind of convenient because these are actually like terms. We can group them together. And then we have a a negative sign and a 2x and a 2x squared. So that would be minus 4x cubed sine of x squared. So cleaning that up, we can group these together to be 6x cosine of x squared minus 4x cubed sine of x squared. So that's part B. Now I think in part C, they just want you to do this without any specific formula, not using any specific function for g. Just saying that the definition is of f of x is x times g of x squared. So, so let's go find some room to do that. You know what I'm going to do? I'm going to start a new slide here. Okay, so now we're going to use, basically we're going after the derivative of f of x. So we're going to need the product rule. So this is my first function, and g of x squared is my second function. So the derivative of the first is 1 times the second function, which is g of x squared, plus the first function, x, times the derivative of the second function. So the second function is g acting on x squared. So it's like you take the derivative of the outside function, you leave the inside function alone, and then you go back and take the derivative of the inside function. So the derivative of g of x squared is g prime, evaluated at x squared, and then we multiply that by the derivative of this guy in here, which is 2x. So cleaning that up, f prime of x is g of x squared plus 2x squared g prime of x squared. Continuing on, now we want the second derivative. So we're going to look at f double prime here, and we're going to take the derivative of this guy, and then we're going to add that to the derivative of this guy. But when we do the derivative of this guy, we're going to have to think about product rule here, because that's 2x squared is one function, and g prime of x squared is another function. So let's get after that. So the derivative of this guy, g of x squared, I'll do him in red, so that would be g prime of x squared times the derivative of what's inside, which is x squared, so the derivative of that is 2x. And now we're going to take the derivative of this thing, which is a product of 2x squared and g prime of x squared. So we're going to add the derivative of the first part, that's the 2x squared part, so that's 4x times the other guy, the second function, plus the original first function, which is 2x squared, multiplied by the derivative of the second function. So the derivative of g prime of x squared, so we're going to take the derivative of the outside function, which is g double prime, because we had started with g prime, so its derivative would be g double prime. Don't mess with the inside function, then go back and take the derivative of the inside function, which would be 2x. So we're going to put that here, g double prime of x squared times 2x. So we can now kind of look for some like terms, and that's kind of what they're getting after in this problem is, you know, after we get this answer, we should check and make sure that it kind of makes sense with the answer we got for part B. So what we should realize is that these two are really like terms. They both have a g prime of x squared, and there's 2x of them in this first one, in the red one, and in the second of them, there's 4x of them. So if we combine those together, we get 6x g prime of x squareds, and then at the end here we've got a 2x in the back and a 2x squared there, so that makes 4x cubed, and then a g double prime of x squared. And I believe the instructions said something like leave your answer in terms of, you know, x squared, g, and g prime, and g double prime or something like that. So we've done that. And I think you can say that if you look at what you have here, you could take from parts A and B and think about, okay, if g of x was given as you know, some linear function in the first one, I think it was sine of x in the second one, g of x squared, would be sine of x squared. And so you could imagine plugging in that the derivative of g prime, or I'm sorry, the derivative of g, and for that g prime, which would be cosine, and drop that in there, and the second derivative of that, which would be negative sine, and putting that in there, I think you'd realize you get the same answer. So now just to finish up with part D, they're asking us to use this table of values, which I just copied down from the other page, to determine what f double prime of 4 is. So we have a template for f double prime here. So all we have to do is everywhere we see an x, replace it with 4, and we'll see what we get. So we're going to use 6 times 4 times g prime of 4 squared plus 4 times 4 cubed times g double prime of 4 squared. So that's 6 times 4 is 24. G prime of 16. Now 4 times 4 cubed is 4 to the 4th. And then that's going to be g double prime of 16. 4 to the 4th is 2 squared to the 4th, which is 2 to the 8th. And let's see, 2 to the 6th is 64, so 2 to the 7th is 128. So 2 to the 8th is 256. So 24 times g prime of 16, which is 8, plus 4 to the 4, which we just found out is 256, times g double prime of 16, which is 9. So I might leave that arithmetic up to you. 24 times 8 plus 256 times 9, and you're going to get your answer. And what the hell, I have a calculator here. I'll go find it for you. 24 times 8 plus 256 times 9, 2496. So there you go. Hopefully that helps out. You just got to keep this stuff squared away by just sticking to the program, using the chain rule and the product rule, and then getting your template for your derivative and then working from there. All right, take care.